In this video, we're going to talk about dot product. So if we have A, which is equal to A1, A2, A3, and B, B1, B2, B3, then the dot product of A and B is given by A dot B, which is equal to, so to find the dot product of A and B, we just have to multiply the corresponding component and add them. The result is not a vector, it is a real number, that is a scalar. So for this reason, the dot product is sometimes called the scalar product or the inner product. So we have to multiply each component. So the dot product of A and B is equal to A1 multiplying B1 plus A2 multiplying B2 plus A3 multiplying B3. Then we get the dot product. It's very, very simple. So this is in three-dimensional form. So what about two-dimensional form? So let's say we have A1, A2 dot B1, B2. How do we find the dot product of this vector? So we have to multiply each component. So here we have A1 times B1, sorry. So A1 times B1. So A1 times B1 plus A2 times B2. So this is the two-dimensional form, and we have the three-dimensional form. So let's take an example. So let's say we have example 1. We have 2, 4 multiplying 3, 1. How do we find the dot product of this? So with this one should be equal to multiplying each component. We have the 2 multiplying 3. So 2 times 3 plus 4 times -1. And when we do it, we should get 2. Now you can try example 2 and see what you can get. So let's say we have -1, 7, 4 multiplying 6, 2, -2. So multiplying each component, we get -1 times 6 plus 7 times 2 plus 4 times -2. And when this one should be -6, this one should be 14, and this one should be -8. And when we do it, we should get 0. So what about example 3? Example 3, we have I plus 2j minus 3k multiplying 2j minus k. Let's find the dot product of this one too. So how do we do this? You can also try to pause the video and try to do it on your own. So with this one, we're going to have, so with question 3 or example 3, we should have 1, which is in front of the I, multiplying. With this one, we don't have any, I is 0 there, so we have 0 plus 2 in front of the j, 2 in front of the j. So we have 2 times 2 plus, we have 3 here, so -3 multiplying -1. And when we do it, we should get 7. So this is dot product. So the dot product obeys many of the laws that hold for ordinary product of real numbers. So these are stated in the following theorem. So we are going to do some theorem here. So first of all, let's talk about the properties of dot products. So if we have A, B, and C are vectors in V3 and C is a scalar, then first property is A dot A should be equal to the argument of A squared. We can prove this. So let's try to prove the first one before we go to the next one. So how do we prove this? So if you have A dot A, this one should be equal to A1 squared plus A2 squared plus A3 squared should be equal to A squared. That's how to prove it. So let's go to property 2. Property 2 states that if you have A dot B, then that should be also equal to B dot A. Property 3, if you have A dot B plus C, then A dot B plus A dot C. These are the properties that you need to keep in your head for the theorem that we're going to talk about. Very, very important. So what about property 4? So 0 dot A should be equal to 0. Property 5, CA, which is a scalar, times A multiplying B, which is dot, should be equal to C, open bracket, A dot B should be equal to A dot CB. This is another property. Then the last property is you have A dot B, which is equal to 0. Then A and B are mutually perpendicular, or A is equal to 0 or B is equal to 0. So these are the properties that you need to take note of before we start the theorem. So without wasting much time, let's start with our first theorem. So theorem 1, if we have a vector A and B which have a length of 4 and 6, then the angle between them is pi on 3. So let's find A dot B. How do we find that if you have a question like this? So with this, note this theorem. So if theta is the angle between A and B, then A dot A should be equal to the modulus of A multiplying the modulus of B cos theta. Right? So when you get this formula, you can use to solve this question. So we have A and B, which A here is 4, B here is 6. Therefore, we have So therefore we have 4.6, which is equal to modulus of A, modulus of B, then cos pi on 3, right? So you can do this and you get 4.6 dot half, and the answer should be 12. Very simple. Now let's look at another example. So with the previous formula that we just did, where we said a dot b should be equal to the modulus of a multiplying the modulus of b cos theta, right? So let's say we have find the angle between the vectors a, which is equal to 2, 3, 2, -1, and 5, -3, 2. How do we find the angle? Just do change of subject and you find the theta. So cos theta here should be equal to a dot b over the modulus of a, the modulus of b here. So first of all, let's find the modulus of a. So the modulus of a should be equal to the square root of 2 squared plus 2 squared minus 1 squared. And when we do it, we should get the modulus of a to be 3. And the modulus of b should be also equal to the square root of 5 squared plus -3 squared plus 2 squared. And when we do it, we should get the root of 38, right? So when you are done with this, then you find the dot product of a and b. So the dot product of a and b should be equal to 2 multiplying 5 plus 2 multiplying -3 plus -1 multiplying 2, and this should be equal to 2. Then when you are done with this, you can just equate them into the formula that we have. So cos theta should be equal to, we had the dot product to be 2, and we have the modulus of a to be 3. The modulus of b is root 38. So when you are done with this, we are finding the theta. So theta here should be equal to the cos inverse of 2 on 3 root 38. And when you do this, point this on your calculator, you should get 84 degrees. So it's very, very simple. It's something that is very, very simple that you can try it on your own. Yeah. So I'll end this video here. In my next video, we will talk about theorem 2. So watch out for that. Thank you for watching this video.